Welcome back to the lab. Autopsy again. March is broken again. You guys know that if you watched the last video. Let's have a look and see what's going on here. Ta-da! So I took that thing there out of that thing there without taking that entire assembly out. A bit of a challenge. Wouldn't recommend it. Got away with it this time. Didn't die, but yeah, not easy. Had to have an extra pair of hands to give me a hand. Thank you, wifey. Does appear to have had reasonable surface area contact. Not full yet. Hasn't 100% bedded in, but not bad. I'd say we're at least 90%, 95% of that face touching. Definitely not holding. I was thinking maybe there was some grease contamination from maybe I put too much grease on the splines or the spigot bush bearing thing, assembly, dooflicky, the bit on the end of the shaft there. You can see a little bit of grease on that, just there, on the shaft. But nah, none of that going on. That's as it came out. No tomfoolery here trying to hide any mistakes or anything silly like that. A little bit of grease there, see? It's still there. Only goes as far as here and stops. Can't see it making any further progress beyond there. Yeah, it's going to be hard to pick up. I'm going to get dirty fingers now. Pretty good on that side. So that's the side that goes on the pressure plate. As you can see, it's not even fully bedded in yet. It was getting there, and I think maybe a little more and it might have held, but we didn't really have that option. There was another session I could have done. Look, my finger's dirty. The things I do for your videos. There was another session I could have done that, I don't know, maybe it might have started coming right, but it's too late now because we've got a mess on the bench. But we've got one of these sitting here. So this is Quartermaster triple plate clutch. They're rated at 900 foot-pounds. We've got about like 550, 600 foot-pounds. So we should be fine with that. That's plenty. This is a flex plate. This came from Race Tech down in Wellington. Flex plate came from our mates at Nissan King, Isuzu Parts World, and the button flywheel that's on the back of that came from Cardwalls, because Race Tech had unfortunately sold out, and we're in a bit of a let's get this done as quickly as possible. And our CV joints that we ordered, they're on their way, and we ordered a new friction face, which I probably won't be using or needing. But I got it just in case for this, to replace this. That's coming from Z1. We'll see that on, I don't know, like Thursday. But we're probably not going to use it. But we'll see how we go. There's a backup plan, right? So now I'm going to go set about trying to organise getting that into some sort of arrangement that replicates this lot, except actually works. So I've got to figure out where those splines sit in there in relation to everything. And set up a flywheel flex plate adapter, whatever, to suit that. So I'm going to clean my finger and get on with that. So we got our button flywheel blank. As it turns out, we could have used anything because we're probably not going to use this part of it anyway. I'll machine the bulk of that out, leave some behind for a bit of rigidity on the flywheel here. Flick on the friction face. Got our 350Z crank, our spare one, sitting in there so that we don't have to reference to the car all the time. I've double checked all dimensions on that. Same as what we've got here, not same as our 300ZX one that I use as a tool in the lathe boxes on the lathe. Never mind. So friction face removed. Where have I put that? Oh, it's on the milling machine. There it is there. There's our friction face. There's wear and heat and whatever. Everyone can look at that and argue over what went wrong. I don't really care. We just need to fix it, and this is the way we're going to fix it. So I figured out all our heights. Got our assembly on there with our splines and all that sort of carry on. Figured out where these plates need to be for all these splines to engage properly. Not worried about the pressure release, the release bearing and all that sort of stuff, which is all on there at the moment. It's actually hard out, bottomed out at that particular point, as you can see. That's fine. That just holds it in a good spot for me to do what I'm doing here. Friction face removed. Button flywheel banged on there. Just marked it with a vivid to give me an idea of where I'm measuring for thickness on this, to see how much meat I've got if I'm going to modify this. So I will have a totu. Definitely is going to be, that's a custom flywheel, no question. I'd rather machine this and take some out of here and get that to work with that than use that flex plate there with a spacer, almost exactly what you see there with that bit of that 300ZX crank, right? So that would need to be spaced up. It's about 13-14 millimeters from that face, so we'd need quite long crank bolts and stuff, and I'm just don't really like that idea. I'd rather fluff around with this. As long as I can attach this to here safely, worst case scenario, pardon me, I can ping all this off, just disappear it, get rid of it, Harry Potter it away, and take a little bit off the back face of this, and then stick that on top of there, and make a better adapter than just a simple bush collar spacey thingy there. It would be something that would be more significant. Anyway, I'm going to fiddle with this. This is going to work as far as I'm concerned. Take that off there, take some material off here, drill some holes through there, take all this crap that we don't need anymore, get rid of the weight. That's going to be fine. Drill out, well, not drill out, bore out the center of this, as I say, leaving a bit there, make it spigot into there, be good as gold. So more measuring, checking, thinking, calculating, double checking, triple checking. That'll be gone soon. That'll be great. Actually, I should show you what I've done on that. That'll be another video. As it turns out, if I bolt directly onto this face, the original Jim Wolf Technologies mounting face for the original friction plate, without doing anything, just bolt straight onto that, we're within 1 millimeter of where I need to be to have those splines and everything lined up pretty much perfect, right? So that could be, it actually is going to be 1 millimeter further that way, like that. So it'll be bang on, and there's heaps at the other side. Those splines at the other side will run into the snout if you go that far, and that's it there. So we're going to end up smack bang in the middle of our splines. Can't complain about that. So that's awesome. And just by fluke, when I chopped, you guys will get seasick, I'm bad at this, hey? When I chopped this bit out of the middle of the flywheel, because we don't need this anymore, I'll put that away somewhere. That's an awesome bit of metal for something one day. When I chopped that out, just because of the way I did it, just by sheer fluke, it ended up spigoting this into the middle of that flywheel absolutely perfectly. That edge that I've got left there sits in there, zero play, will center itself, perfect. So I was thinking I was going to machine this surface down like 1 millimeter, and that would allow that to spigot inside the lip that would be left, like this lip, except smaller over here. Don't need to, that'll be great. All we have to do now is find a nice place where it's not too close to some holes. That's actually probably pretty good where it is there, depending on what's on the other side of that. And make a little punch so we know we get exactly in the center of these holes, not off to one side or anything. Do all those, drill, tap, helicoil, because stronger, and we can test assemble it. There we are, something like that. I do actually have some bolts, some cap screws. I could screw this onto here. I've at this point only drilled and tapped into the aluminium. I do have 4 helicoils, but not 6, so we can't make it 100% go today anyway, so it's no big deal. Ideally this should go away, and we should put a concentric thrust bearing on there, and we should also change that bearing size It's just going to be a long way out on the fingers. It's going to make the pedal very, very hard to push. So we need a smaller thrust bearing for that. What have I got? That might be smaller. Probably not. That's the same. So, I mean, I could pop down to our mates at Repco and they might have something on the shelf to sort that, but no rush. It's only Sunday. We've got 3 weeks, I think, and we're trucking along fairly well. Yep. It's good. All right. Minor disaster. Not really. Not a big deal at all. I said that was running concentrically in the center here. Well, it turns out when you put it on that machine over there with the DTI and check it, it wasn't. It was close, but it wasn't close enough for me. So I said we can skim a millimeter off here. I've done that. Clocked this up, dead true, within 0.01 of a millimeter or something like that. It was so close, it wasn't funny. Skimmed that, a millimeter, made that fit inside here. Spigot inside there, and also spigot inside there into that. Less than 0.1 of a millimeter run out on that, which ideally you want at 0. It's a bit hard to do with the gear I've got, so I'll clock it up and mark it all when it's in its best position. Maybe put a dowel on it or something like that, or mark it so I know it's in the same spot every time, and I'll go and get it balanced. ATL can do that, and that'll save it shaking the engine to bits. Want to know how to get your threads nice and square when you're drilling and tapping into things? We are going to helicoil this later, so it doesn't really matter, but put it in a drill press. Don't turn the drill press on. That'd be real dumb. Just turn it by hand. Use one hand to lower it down, to put the pressure on it, like that, and turn it by hand with the other. Done. Easy. Okay, so that's been a bit more challenging than what I was expecting. Dead crankshaft in there, all clocked up, flywheel in here, bolted up, clocked up as true as it'll possibly go, which is, yeah, it's within like 0.05 of a millimeter. It's almost impossible to get it to run dead true as such on this lathe. It's not a big lathe, bearings have slop in them and all that sort of carry on. But anyway, here's our DTI. Managed to get this running basically within 0.1 of a millimeter. Maybe. Yep. Pretty much 0.1 of a millimeter. 0.1 of a millimeter for you to visualize is that much. Can we see daylight through there? Oh yeah. So it's not much. 40 thousandths of an inch is 1 millimeter. So we're talking, it's got to be 4,000, something like that, whatever. Happy with that. I thought I was going to have to go and get that sorted somewhere else with someone with some better gear, but pretty confident that now runs true. So that's great. We don't want that out of balance because it'll destroy everything. There's a bit of material here that can go away if I want to. I don't think we need to make the flywheel any lighter on this car than what it is already. It was already pretty zing-zingy, and our rotational mass is reduced a bit. I think this whole assembly, by the time you put all plates in there, is probably about the same weight as our thing on the floor there. I'm going to weigh it actually. Let's do that later on. Of course, this is all rotating masses, smaller diameter. So things will whiz up faster than what they did before, which will make the car even more uncontrollable. So that's going to be great fun. Rough man's check for alignment of the bell housing to the shaft. This is not the perfect way to do it. There's a fair bit of play in these Nissan gearboxes here anyway, so it's going to be really difficult to do it 100% accurately. But I've set this up on here, clamped it on there. We've got nothing, no clearance at all really. Might be a bit more down the bottom there. That's the clutch plate making that noise. You can see we're paper thin clearance here. Just a tiny touch up here somewhere. Pretty happy with that. Alignment's supposed to be within, I think it's like 4th thou, 6th thou, something like that. It's, you know, it's tight. It's supposed to be really good, because otherwise you're going to have issues with your 3 plates trying to do the old shuffle, because we don't have a spring in the middle here. Like with this, you can have quite a bit of misalignment, and the center will just take that up. And as we saw, that one that I killed, which I think it's over there under my mess, sorry, that had some cracks around here. So I just wanted to make sure there wasn't an issue with this that caused those cracks, that is then going to cause massive dramas with that. So basic check like that, that appears to be okay. Certainly within, you know, pretty close margins of accurate. I'm not going to claim it's 4th thou. It might be, but there's a bit of play in these shafts anyway, like I say. So if this is not 100% perfect, that shaft will just realign to suit to a certain extent, right? So if we're putting in a fancy sequential gearbox, which I hope to be doing one day, obviously you go to a great deal more effort than a rule with a G-clamp on there. But I mean, the real way to do it is actually with a DTI on here, and it's not actually a heck of a lot fancier than that. Getting pretty serious now. All mounted up, Loctited. She's ready to go. Well, that part of it is at least. DTI on there again. Carefully turning the engine. Of course, it's just on its 2 mounts. It doesn't have the torque plate at the back, so it's only mounted on the end of that, whatever we're going to call that, tube, engine mount, whatever. So it does move a little bit while I'm turning it with the torque wrench, so I just have to take that into account and just turn it a little bit at a time and pause and watch the needle. I've got about 0.08 of a millimeter run out on that, which in old school numbers is maybe 4 thousandths of an inch. So that's acceptable. That's within the tolerances. So good, happy. I've checked, I think I showed you, checked the gearbox bell housing for run out and stuff, and that's all kosher. So we are literally sort out the bearing. Let's show you what I did with that. And we can put it back together. I've lost the bearing. Can you guys see it? Oh, I can see it now. So we need a smaller bearing on the end there to suit the fingers that are in the quartermaster thing. This is too much. She's too big, eh? So unfortunately, don't worry about that clip stuck on there. That one there will just press onto the end of that. That'll lower the profile and decrease the diameter of the bearing, and it's actually just going to work lovely, hopefully. I'll test fit all that in a minute and see where we're at. On the home straight now, guys. Only one shaft in at this point in time, waiting for those other CV joints. I could just leave this one out, eh? It'd be lighter and the car would go faster. What do you reckon? Won't get any horsepower from there to there, but that won't matter. It'll be so much lighter. It'll be awesomeness. Anyway, the old torch and the bell housing there, so we can see what's going on. We've got a great big hole in the side of the bell housing. Like I say, that's for our prop shaft. Originally that ran a bit lower, so this was cut out down here, but it doesn't matter. It gives us some lovely views of the activities in here. Now the gearbox is in 4th gear and the clutch pedal's jammed down. You guys can see the loveliness that goes on inside there. So that's pretty nicely disengaged with our oh, you can't see it very easily, calibrated bolt in there just to figure out the length of the rod that we need. That would actually be fine, just go like that almost forever, but it won't stay like that. Checking the travels and everything. I did originally take that bolt that you can see that's quite close to the lever. I took that out and put a dome screw in there, cap bolt or whatever instead. Focus is all rubbish, isn't it? But then it over travels anyway at that point, so that's a good stop there. And there's a stop on the pedal. We're pretty much on the stop on the pedal at this point with the clutch disengaged, so everything's worked out really well. This bit of a creak there. This lever ended up smack bang in the middle of the window, which is ideal as far as I'm concerned. Some might say different, but that's what I reckon. So she's all good, all back together, mostly back together, not all. Some shields and stuff. Roll of carbon fibre hiding over here. Panels. Carbon fibre. Panels. We'll see how much time I've got. It'd be nice to reduce the weight. There's quite a bit of weight there. Maybe 2-3 kgs there. It'd be good to get rid of that. Spare crankshaft. Right. That'll do for now. Don't forget to like, share, subscribe. All that sort of carry on. I'm going to wait for these CV joints to turn up from Murica. They're on their way. Our backup plan, which is a new... Where's it gone? Oh, it's under the mess here. New friction face. That's the old one there. Here's the new one in here in this box from our mates at Z1. They got it here quite quickly, even though it was a pandemic. Oh, look at that shape too. So I'm going to wait for the new CV joints to turn up. The shaft's on the bench there. I've measured everything. It should just bolt right up. We'll see. Smash it together and we'll try and get it on dyno and crank up the boost until we break something and then miss the final round. Maybe not do that. We'll 20 psi. Let's go 20. It's on 17 at the moment. It was 420 something, 430 whatever kilowatts at the hubs. So we got much colder air intake temp now, so we can run a little bit more. So we might run around 20 psi and 450, 460 kilowatts at the hubs. Maybe some more. Certainly won't be slipping the clutch. Gearbox can probably handle that. Transfer box definitely. It's just the turbos really are just maybe not big enough to do that, but we'll see what happens. Right, cheers, bye.